Hey everyone, welcome to Simplilearn's YouTube channel. In today's session, we will be discussing about the delegates in C#. But before we begin, let me tell you guys that we have daily updates on multiple technologies. So if you are a tech geek in a continuous hunt for latest technological trends, then consider getting subscribed to our YouTube channel. And don't forget to hit that bell icon to never miss an update from Simplilearn. Now without further ado, let's get started with the agenda for today's session. First and the foremost, we will define delegates in C#. We will then learn why and when to use delegates in C#. Later, we will discuss how to declare delegates in C#. Then, we will learn how to initialize and invoke delegates in C#. After that, we will look at the different types of delegates in C#. Finally, we will see some major differences in how delegates work with names and anonymous methods. I hope I made myself clear with the agenda. Now, let's get started with our first topic, that is the definition of delegates. So, what exactly are delegates? A delegate is an object that refers to a method, or it is a variable of the reference type that can hold a reference to the methods. For example, delegates in C# are analogous to function points in C or C++. It provides a method for specifying which method should be called when an event occurs. Delegates are commonly used to implement events and callback methods. All delegates are derived implicitly from system.delegate class. Here is a diagram that shows how delegates work, which is completely similar to a pointer to the function. For example, the caller invokes a delegate, an object that refers to a method or a reference type variable that can hold a reference to the methods. For example, if you click a button on a form, the program will invoke a specific method. In a nutshell, it is a type that represents references to methods with a particular parameter list and return type and then calls the method in a program for execution when needed. For a better learning experience, here is a pictorial representation of the given example. Now, we will look at some essential aspects of delegates in C#. Firstly, delegates are a good way to encapsulate the methods. Next, delegates is a library class found in the system namespace. After that, delegates can also be used to invoke anonymous methods. Following that, delegates are primarily used to implement callback methods and events. Next, as two or more methods can be called on a single event, delegates can be chained together. Following that, it is unconcerned about the class of the object it refers to. Finally, in certain contexts, anonymous methods of C# 2.0 and lambda expressions of C# 3.0 are compiled to delegate types. These features are sometimes referred to collectively as anonymous functions. After defining delegates, we will look at why and when to use them. Programmers are frequently required to pass a method as a parameter to other methods. Delegates are created and used for this purpose. For example, a delegate is a class that contains the signature of a method. Although it can be used in any context, it is frequently used as the foundation of the C# event handling model. Delegates can be thought of as giving a name to a method signature. Here's an example of the delegate on my screen, namely the delegate function. The delegate can be assigned to any method that matches the delegate's signature, including the return type and parameters. Now, let's look at why we need delegates in C#. Delegates in a nutshell are object-oriented, type-safe, and very secure because they ensure the signature of the method being called is correct. Delegates make event management simple and easy. After determining when and why we require delegates in C#, we will now try to figure out how to declare delegates in C#. There are 3 steps in defining and using delegates. Delegate keyword is used to create a delegate. First, we add the attribute, the modifier, the delegate keyword, the return data type, the delegate name, and finally, the formal parameter as an argument. The modifier can be any following keywords or a suitable combination of new, public, private, protected, or internal. Any of the data types we have seen can be used as the return type. It could also be a void data type or the same name of the class. Name parameter must be a valid C# name. Because a delegate is a method definition, you must use the parenthesis required for all methods. Leave the parenthesis empty if this method will not accept any arguments. Here's an example with an access modifier set to public and the delegate's name is example delegate with the int data type and string s as a formal argument. The preceding delegate can refer to any method that accepts a single string parameter and returns an int variable. After we understand how to declare delegates in C#, now we will try to know how to initialize and invoke delegates in C#. We use the same example while declaring the delegate to initialize and the delegate with the keyword new as shown on my screen. We can create two objects, ex1 and ex2, that is example 1 and example 2. Next, we will look at how to invoke or call objects in delegates. We call the objects by using the object's name followed by parenthesis and finally a colon to end the calling procedure. Let's look at a practical demonstration of declaring and initializing and invoking delegates in C#. Now we are on the practical mode and we have started our Visual Studio. So you can see on my screen we have an example. This program declares a delegate, namely a calculator. This program declares a delegate, namely a calculator, with a formal argument x using system. We created a delegate example class with the access modifier public and the static keyword. The keyword static denotes that a class has only one instance of the member. We then declare a static variable named value with the value 10 assigned to it. We then define a static function addition with the same formal argument x. We calculate addition as the value equal to the value of plus x. Finally, we return the result of adding value. We then define a static function subtraction with the same formal argument x. Then we calculate subtraction as the value equal to value minus x. Then we finally return the result of subtraction value. Similarly, we define a static function multiplication with the same formal argument x. Then we calculate the multiplication as the value equal to value multiplied by x. And finally, return the result of multiplication value. Lastly, we declare another static function by the name division with the same formal argument x. Then we calculate division as the value equal to value divided by x. And then we return the result of the division value. Later, we define another function called getValue, which displays the results of all operations performed in the calculator. Finally, we enter the main function, where we see how we initialize and invoke the objects and delegates in practice. For example, we created 4 objects: calculator 1, calculator 2, calculator 3, calculator 4, and used new keyword to perform the 4 operations, which are addition, subtraction, multiplication, and division. Next, we call all 4 objects by assigning values to x, such as here we assign 20 to x to perform addition because the value was initially assigned with 10. So the sum will be 30. After that, we divide addition as 30. Next, to perform subtraction, we assign x to 3 because the value was previously calculated as 30. So 30 minus 3 equals 27. Similarly, we assign 5 to perform multiplication. And finally, we assign 5 to x, which now has a value equal to 135. We divide 135 by 5 and get 27. So now I hope I made myself clear with the code. Let's quickly try to run this and see the output. There you go. The program got successfully executed and the results are on the output terminal. Now in this Delegates in C# tutorial, we will look at some different types of delegates in C#. In C#, there are 3 types of delegates. First type of delegate is a single delegate. Followed by that, we have a multi-delegate. And finally, we have a generic delegate. Let's look at all these type of different delegates in detail. So first, let's try to figure out what a single cast delegate is. This delegate can only refer to one method at one time. For example, single cast delegates refer to a single method with a matching signature. The system generates single cast delegates.delegate. Let's see a code demonstration for a single cast delegate for better understanding. This single cast delegate program includes the single delegate namespace, then declares delegate 1 with formal arguments a and b of integer data type and public access modifier. Then we make a class program in which we define an addition function, calculate the addition of a and b and display the result of the addition function. Similarly, we make a subtraction function in which we calculate the subtraction of two variables a and b and show the resultant difference. Finally, we reach the main function where we rename the object of class program to obj using the new keyword. Then we created two more objects, d1 and d2. d1 for addition with two values of 100 and 200 and d2 for subtraction with the same 100 and 200. Now let's quickly run the code and see the output. Now the next type of delegate is the multicast delegate. So let us attempt to comprehend multicast delegates. This kind of delegate can refer to multiple methods that have the same signature at one time. Let us see a code demonstration of the multicast delegate for a better understanding. This program uses the namespace delegate and then declares delegate as a multi-delegate with formal arguments a and b. We define the addition and subtraction functions in the class program, which we declare and calculate as plus b and a minus b respectively. Then, the main function, we create the class program object p1, then we declare md1 and md2 objects for addition and subtraction operations. Then we assign md1 to md1 and md2, giving a value of 100 to a and a value of 200 to b. Let's try to quickly run this program and see the output. Let us now look at the third and final type of delegate, generic cast delegate, and try to understand it. Generic delegate was introduced in .NET 3.5 and did not require the delegate instance to be defined to invoke the methods. There are three types of generic cast delegate, which are function delegate, action delegate, and predicate delegate. Now, for a better understanding, let us look at the three generic delegate types in greater detail, complete with code examples. Let us look at the first type of generic delegate, the function delegate. In C#, the function generic delegate is found in the system namespace. This delegate accepts one or more input parameters and returns a single output parameter. The final parameter is regarded as the return value. In C#, the function generic delegate can accept up to 16 different input parameters. It must only have one type of return. The return type is required, but the input parameter is optional. One thing to keep in mind about function generic delegate is, in C#, you must use the function generic delegate whenever your delegate returns a value, whether it takes any input parameters or not. Let's look at the second type of generic delegate, that is the action generic delegate, and try to understand it. In C#, the action generic delegate can also be found in system namespace. It accepts one or more parameters and returns null. This delegate can accept up to 16 input parameters of different or the same type. One note to remember about action generic delegate is, when your delegate does not return any value regardless of whether it takes any input parameters or not, you must use the action generic delegate in C#. The last and final generic delegate type is the predicate generic delegate, which should be understood. In C#, predicate generic delegate can also be found in system namespace. This delegate is used to validate the method's criteria and returns the result as a boolean, either true or false. It only accepts one input parameter and always returns a boolean value, which is required. This delegate can accept a maximum of one input and always returns the boolean type's value. One note to remember about predicate generic delegate is, you must use predicate generic delegate in C# whenever your delegate returns a boolean value by taking one input parameter. Now let's get back to the practical mode and take a look at the code demonstration that will provide a clear picture of generic delegates including function, action, and predicate generic delegates. Now this is an example for generic delegates. First we have a main method. Followed by the main method, we have our sum number. The SumNumber1 method accepts 3 arguments and returns a double value. In this example, we'll use the function generic delegate to accomplish the same thing we did first. Similarly, number 2, that is sum number 2 method. This method accepts 3 parameters but returns null. In this example, we'll use the action generic delegate to accomplish the same thing, just what we did. Followed by that, the length methods check accepts one string argument and returns a boolean value. In this example, we will use the predicate generic delegate to accomplish the same. As shown in the preceding code, the function generic delegate accepts 4 parameters, the first 3 of which are input parameters and the fourth one is the return value. Then we pass the sum number 1 method to the function generic delegate function object, which will be executed when the function delegate is invoked. The preceding code shows that the action generic delegate accepts 3 input parameters. First, we pass the sum number 2 method to the action generic delegate function object, which will be executed when the action delegate is invoked. The preceding code shows that the predicate generic delegate accepts one string input parameter named 1. We pass the check and the length repeat. We pass the check the length method to the predicate generic delegate function object, which will be executed when the predicate generic delegate is invoked. This delegate can only accept one input parameter and 0 return values. Instead, it returns boolean value by default. This program's output shows the sum of all the 3 numbers 1, 2, 3 of the function sum number 1, which gives 10 plus 12.15 plus 14.78, which gives a double value of 65. Similarly, the sum number 2 function returns the sum of all the 3 numbers 1, 2 and 3 as 20 plus 25.45 plus 12.45, which is 57.90, and the length check function returns a boolean value if true, the length string hello is less than 10. The final topic we'll go over is delegates using the name and anonymous methods. A name method can be associated with a delegate. When you use a name method to instantiate a delegate, the method is passed as a parameter. For example, first we declare a delegate with the formal argument x, then we define a named method, and finally we instantiate the delegate with the method as a parameter. This is accomplished through the use of a named method. Let's go over some delegates with named methods. Delegates built with named methods can encapsulate either a static or an instance method. In the older versions of C#, named methods were the only way to instantiate a delegate. However, if creating a new method is unnecessary overhead, C# allows you to instantiate a delegate and immediately specify a code block that the delegate will process when called. A lambda expression or an anonymous method can be included in the block. Let's go over some delegates with anonymous methods. As the name implies, an anonymous method does not have a name. For example, in C#, anonymous methods can be defined with a delegate keyword and assigned to a variable of delegate type. Here is an example for a delegate with an anonymous method on my screen. Anonymous methods can access variables defined in outer function. Here's an example of anonymous method being passed to a method that accepts the delegate as a parameter. Let us now discuss lambda expressions. A lambda expression is an anonymous method for creating delegates or expression tree types. In 2007, Microsoft introduced lambda expressions in C# 3.0. Many developers frequently confuse anonymous methods with lambda expressions. Let's compare the anonymous method and the lambda expressions with code example. This example will provide at least 2 concepts. The first thing about working of the parameterized delegates, and the second about comparing anonymous methods to a lambda expression. You will notice that you have passed parameter number value 100, but anonymous method can omit it, and the program will still run it. Let us execute this code and see the output. There you go. The program got successfully executed and the message inside the function is being displayed. This is the function. You will notice that you have passed parameter number value 100, but anonymous method can omit it and the program will still run. And similarly, the function is also displaying the message inside it. That is, this is the function. Now, let us see some limitations of using an anonymous method. The first one is it can include jump statements such as go to, break, or continue. It can access an outer method's reference or out parameter. It can contain or access dangerous code. It cannot be used on the operator's left side. Now with that, we have come to an end of this tutorial on delegates in C#. If you have any queries regarding any of the topics covered in this session, Or if you need the code that we have explained during this session, then please feel free to let us know in the comment section below, and our team of experts will be happy to resolve all your queries. Until next time, thank you, stay safe, and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.